My dear children, in the earlier chapter, we took a sound knowledge about physical changes and about the chemical changes. Now, in this chapter, we'll be discussing further things related with the physical changes especially. Right? Here we are going to discuss about especially about the state changes that's going to happen in matter. So in the earlier chapter also I told you that if a certain state change is going to happen, right? If a certain state change is going to happen, these state changes are considered as physical changes. As no new substances are getting created during a state change, these things are considered as physical changes, right? So, turning a solid into a liquid, turning a liquid into a gas, right? Like that way, those kind of stuffs are, or those kind of examples are considered as physical changes. So, here we are going to get some further idea about the change of a state, right? Especially here we are discussing, or here we are going to get some knowledge about state changes in matter. So you know that state changes are physical changes. These things are physical changes. So here we'll be discussing changes of state as physical changes. Under that, first of all, we are gaining an understanding about the changes of state, right? We are going to gain some kind of an understanding about the state changes, right? So, especially we are discussing about the special terms which are given for the changes in state. If a solid thing is getting converted into a liquid, what's the special term which is given for the turning of a solid into a liquid, right? And we'll be conducting several experiments so that you can follow up. So first of all, the first and foremost experiment given in here is this. The activity 1, first experiment related to the physical changes, right? So you are given with these materials. Let's see what are the materials. You'll be needing a boiling tube, right, my dear children? So we are going to take a piece of wax, place it in a boiling tube and heat it by using this Bunsen burner, right? You know that when I'm going to heat a piece of solid wax, it's getting converted into a liquid. So here solid is getting changed to liquid, right? So this is the activity that we are going to do right now. So we'll name the other materials then. So you'll be needing the Bunsen burner, if you don't have the Bunsen burner, you can get the spirit lamp as well, solid wax, you can get a piece of candle, then forceps. We have to handle it now. We have to handle the boiling tube onto the flame. So therefore we need the forceps. So these are the materials that we need. Right, my dear children. So let's move on to see what is the method of doing our experiment. So this is a really simple experiment actually. What you have to do is, you take the piece of solid wax, place it on the boiling tube, and we have to heat it over the flame given in here, right? Then after that, we have to keep it for some time. let it cool down and observe what is going to happen once again. Okay, right. So let's write down the method then. Method, it's really simple. What do you have to do? Place a piece of solid wax in the boiling tube. Heat the boiling tube well. Heat the boiling tube well. Allow the boiling tube here you have to observe. Then allow the boiling tube to cool. Then once again observe. So this is the method of doing our experiment. It's really simple. We have to place a piece of solid wax in the boiling tube. Heat the boiling tube well, and we have to observe what is going to happen. So it's obvious to us that you know that solid wax is going to convert into a liquid wax. Then we have to allow the boiling tube to cool somewhat. Allow boiling tube to cool somewhat. And after that also we have to observe. Right? So you know that when heating, a solid is getting converted into a liquid. Upon cooling, that liquid is getting once again converted into what? Solids. Like this. I'm starting with ice. I can turn ice into water by heating. Right? Then once again I can convert this water to ice by cooling. Heating means supplying heat. Cooling means removing heat. See, this is the state change that's going to occur in here also. I'm going to take solid wax and I'm going to heat it. Then in that case it is getting converted into liquid. When I'm going to cool the liquid, or when I'm going to remove heat, when I'm allowing it to cool down, once again it is getting converted into a solid. State change, right? So this is the experiment, the simple experiment that we are going to discuss in here, my dear children. So it's really simple. So let's head on to the lab and let's heat up this solid wax, and we'll see what will happen when heating and what will happen when it is going to cool down. So let's head on to the lab and we'll conduct the experiment. Right, my dear children. Now in this activity we'll be observing somewhat other different examples to get some idea about chemical and physical changes. So especially here I'm going to show you some physical changes, right? So we'll observe what kind of a physical change is going to occur when I'm going to heat these pieces of wax. This is solid wax pieces, right? You can observe very clearly solid pieces of wax. See, right? Now what I'm going to do is I'm going to take a boiling tube and I'm going to insert these wax pieces into the boiling tube gradually, and I'm going to heat it by using the spirit lamp over there. So when I'm going to heat this solid wax, you know that it will turn into a liquid. The solid wax will turn into a liquid. So it's clear to us that when I'm going to heat this container or heat this boiling tube, the solid wax will turn into a liquid, means that solid nature is getting changed into liquid nature or liquid state. So we'll carry out the experiment to get the relevant observation. So I have a crucible here to hold the boiling tube, right? Then the spirit lamp, so I'm going to heat it. I'm going to heat the boiling tube gradually. So you can see clearly the solid wax is turning into a liquid inside the boiling tube. See children, you can see that it's clearly turning into a liquid. Right. So here you can observe the liquid form of the wax, right? Now what I'm going to do is I'm going to keep this system and allow it to cool. I'm going to keep this system and allow it to cool. So what will happen when cool in this system? Let's observe what will happen when cool in the this liquid wax. Okay, so after that I'm going to explain like what kind of a change occurred here. Actually, you know that this is a physical change, but I'm going to specially explain the name or the term which is given for the each of the change in instance or the state. So I'll keep this boiling tube in a position so that it will cool gradually. Right, my dear children, so observe what can you see at the bottom of the beaker. You can observe the solid wax once again. See, so I have cooled the liquid very well. See, I have cooled the liquid very well, and I have turned that liquid wax once again to a solid wax. So this is a wonderful example for a physical change. So when I'm heating this solid wax, it is getting turned into a liquid wax. Once again, when I'm cooling this liquid wax, it will turn into a solid wax. So this is a wonderful example for a physical change. Here, the solid has changed to a liquid, the solid state has changed to a liquid. Once again, the liquid state has changed to the solid by reverting the temperature or the heat energy which is supplied. So, this is a good example for a physical change. Now, let's move on to observe another experiment to see these state changes in matter. So, my dear children, we conducted the activity and you could observe that when I am heating the system or when I am heating the solid wax is getting converted to liquid. Okay, solid wax is getting converted to liquid. When I am cooling it down once again, liquid wax is going to convert into solid. So here we can see the state change between the particles. So wax particles is changing solid to liquid upon heating. Then once again, wax particles getting converted from liquid wax to solid wax upon cooling. So we can write our observations. When heating, solid wax converts to liquid. So this is our first observation. When heating, solid wax converts to liquid. Then in the next step, upon cooling, liquid wax turns to solid. Right. So these are the two main observations that we can take from the experiment. First one is when heating, solid wax converts to liquid, and upon cooling, liquid wax turns to solid. So what is the conclusion from this activity? Finally, we can say that state changes, right? When heating and cooling, we can observe a state change in this process. Okay, so when heating, solid substance change to when heating, solid substance changes into liquid. When cooling, a liquid it changes into a solid. It changes into a solid. So we can finally say that when heating, solid substance it changes into liquid. You have to include it here. It changes into liquid, right? When heating solid substance, it changes into liquid. When we are heating a solid substance, it is getting changed into liquid. Once again, when cooling a liquid, when you are cooling a liquid substance further, Like we can take water and we can place it in a refrigerator and we can cool it down. So it changes into a solid at that process, right? So in that situation, water is getting converted into solid ice, right? So this is the final conclusion that we can take from the experiment. I'm going to further clarify. Take slide somewhat up. Let's further clarify this thing like this. Solid, heating, liquid. Okay, then next one, liquid, cooling, liquid, cooling, solid. These are the two main state changes that we can observe during this experiment, right? So these processes, turning a solid into a liquid and turning a liquid into a solid, we'll see what are the special terms given for these things at the end of our chapter, right? So up to now, this is enough. This is what do you mean by a state change. So in this activity, I have changed solid wax into liquid, then once again liquid into solid. So let's move on with our next content. The second activity, to gain an idea about the physical changes or state changes. So here, second activity, within this activity, will be converting ice into a liquid and into a gas and so on. Okay, so we'll be needing ice. Once again, Bunsen burner or else a spirit lamp. Bunsen burner or else a spirit lamp. Then we'll be needing glass sheet. A glass sheet, right? Then tripod. Then finally, to place water or to place ice and water and all the stuff, we'll be needing a beaker. So these are the materials that we need. We'll be needing a beaker, Bunsen burner, a glass sheet, a tripod, ice, right? So method is really simple, my dear children. You place some ice on the beaker, then place it over the tripod, take the Bunsen burner and place it below the tripod, heat the system very well and vaporize water. When vaporizing, take the glass sheet and place it above, right? Place it above the beaker and observe what's going to happen when water is going to vaporize and hit on this glass sheet. Okay, definitely you can observe several droplets of water. It's because that when gas is getting hit on the when water vapor is going to hit on the glass sheet, when it is going to take some amount of time, it's getting cooled down gradually. So during that process, once again, water droplets are getting created, right? So we need glass sheet to place it over the beaker to observe whether water droplets can be created by using steam or water vapor or not. Right. So this is the way of conducting the activity. So we'll see, or we'll write down our method. So method is really simple. I told you what you have to do. Place. So first of all, we'll draw a simple figure so that you can get a good idea. This is ice. Right. The tripod. Then our Bunsen burner. Then we have to place that glass sheet near the vaporization, near the vaporization of water and ice, like this. Right. So we'll name the instruments, my dear children. We'll name the instruments. So this is this one. We'll mark the things first and then we'll name. Okay. Now let's name. This is the beaker with ice. Beaker with ice. The tripod. This is the Bunsen burner. This is the glass sheet. Right? So this is the figure. Okay? So this is the way of conducting the experiment. So we'll write down the steps then. Set the apparatus. Set up the system. As per to the figure. As per to the figure. Heat the system well. Heat the system well. When water is evaporating, place the glass sheet. Place the glass sheet above the beaker. And observe. Right. So this is the way of conducting the experiment. It's really simple. You have to keep the setup like this. Okay. Then what you have to do? We have to heat the system very well. You have to heat the system very well like this. Then when water is evaporating, you know that ice is going to turn into liquid and it's going to evaporate. So when water is going to evaporate, we have to place that glass sheet over the, right, above the, right, we have to place it above the beaker like this to capture some amount of water droplets, right? So when water is evaporating, place the glass sheet above the beaker and observe. So this is the way of conducting our experiment. So let's head on to the lab and we'll conduct our experiment and we'll see what are our observations, and from that how to arrive into a conclusion. Right, my dear children, now in this activity we'll be observing some other cases where we can identify its state changes in matter. So I have some ice cubes with me right now, right? So this is ice cubes. So you know that ice cubes are made up with water. When I'm going to freeze water by cooling, you know that ice cubes are going to be created. So I'm going to have some ice cubes. I'm going to put into this beaker, the smaller beaker. Right. Now what I'm going to do is I'm going to supply heat by using the spirit lamp and heat this thing up. So when supplying heat gradually to the system or to the beaker, this will turn into, this means ice will turn into a liquid, right? Ice will turn into a liquid. Now in the earlier case, you observed that the solid wax also turned into a liquid wax. Now in this case, solid ice cubes is turning into liquid ice, liquid water. So we'll give some time. It's heating up gradually, so we'll give it somewhat more time. So you can here observe that gradually the ice is going to melt down and turn it into a liquid. So like in the previous case also, we heated up a piece of wax, some pieces of wax, and during that process we could observe that the wax is going to convert, or wax is being converted into a liquid. So once again when I'm going to cool it down, the liquid wax turned into a solid. So like half of the ice cubes now being turned into liquid water. So we'll give some more time so that all the ice cubes or all the ice will turn into liquid. Right, my dear children, now you can see that all the ice cubes, all three ice cubes has been converted into liquid water right now. So I'm going to supply further heat. I'm not going to stop. I'm going to supply further heat, right? So let's keep the system in the same position so that it would heat up quite more. So my dear children, now when you take a solid, Here you observe two states or two examples where a solid is getting converted into a liquid. So in the first case, we heat up several pieces of wax and we turn those things into liquid wax. Okay, we turn those things into liquid wax. Here we heat up some ice cubes and we turn those ice cubes into liquid water. So here the solid state is getting changed into the liquid state. This transition of state from solid to liquid, the transition of this state from solid to liquid is called as a fusion. This is called as a fusion, right? So this transition is specially called as fusion, or in normal terms we refer that thing as a melting. So here we have melted solid wax and turned it into a liquid wax, right? And ice also we have melted to make into a liquid water. Now the system has somewhat heated up. Now I'm going to place, I have a petri dish with me, right? See, I have a petri dish with me. Now I'm going to place this petri dish somewhat above the system or the beaker. Here you can observe when I'm keeping this thing at the top of the beaker, some kind of a vapor is getting formed on the petri dish. See, you can observe it clearly. Some kind of a vapor, some droplets are getting created on the petri dish. So this vapor is getting deposited on the petri dish. So this vapor, you know, these are water vapor, and when it is going to hit on the petri dish, it's getting cooled down. See, you can observe it very well. See, there are droplets of water in here, right? So I'll keep it once again. So you can see that water vapor is getting deposited on the petri dish. Right. So when I'm placing this petri dish above the system like this, right, you know that the vapor coming from the system is going to hit on the petri dish, and after some time the water vapor is going to be cooled down and turning into water droplets. So in this state you can see that the gaseous water vapor is going to deposit as liquid droplets on the petri dish. So in this state change, we can observe a gas is getting converted into a liquid on the petri dish. This state change is specially referred as the condensation. So here we can say that water vapor has condensed into water droplets when I am placing this petri dish above the beaker, right? So these are some examples that we can observe the state changes in matter. So let's continue some other examples rather than these things to observe what are the other instances where we can observe these state changes. Right, my dear children. So we conducted the experiment at our lab. So you could observe that when I'm going to heat the system, ice is getting converted into liquid water. When I'm further heating it up, that liquid water is getting converted into water vapor or steam. When I'm placing that glass above the beaker, I could also observe that water vapor is going to hit on the glass sheet, and when it is going to take some amount of time, it's going to once again convert into water droplets upon cooling. So here it's obvious to us that ice is getting converted into liquid water, and liquid water is getting converted into once again steam or gaseous water vapor upon providing heat. And if I'm going to cool down that water vapor, which is going to emit from the system by using that glass sheet, once again I can create water droplets. Plus, if I'm going to cool it further by placing it in the refrigerator, I can recreate ice. So here, solid is getting converted to a liquid, then liquid is getting converted to a gas. Right? So it's a good experiment to explain about the physical changes or state changes in matter. Right? State changes in matter. So we can write our observations like this then. Ice turns to water when heating. Ice turns to water when heating. The next one, water evaporate. Water evaporates to create water vapor. Or steam. Right? Water evaporates to create water vapor. Right? Water evaporates to create water vapor. Then the third one, when glass sheet is placed above the beaker, steam is getting converted back to water droplets. So these are the observations that you can take from the experiment. Number one, ice turns to water when heating. That's the first observation. Number two, water evaporates to create water vapor or steam. When glass sheet is placed above the beaker, steam is getting converted back to water droplets. So when you are placing that glass sheet above the beaker, once again that gaseous water vapor is getting converted into water droplets because of cooling. So here you can observe all three state changes in this experiment, right? So our conclusion is that In the earlier experiment, we took only solid, liquid, liquid to solid. No, here we can observe all three state changes. So here, upon heating, we can say that solid is getting converted to liquid and liquid into, once again, gas. Right, upon heating, we can say that solid substance is getting converted to liquid substance and liquid substance is getting converted into a gaseous substance upon heating. Then in the next, when it is going to cool down, by placing like that glass sheet over there, we cool it down. No, when you are placing glass sheet, when water droplets or when that steam is going to hit the glass sheet, some amount of temperature is going to reduce, heat energy is going to lose. So due to that, when losing heat energy or when losing temperature, droplets are getting created, water droplets are getting created. So upon cooling, we can say gas is getting converted into liquid. Then that liquid is once again converted into solid. Right? Upon cooling, this is going to happen. And upon heating, the above state change is going to happen. So these are the main state changes that we can observe in this experiment. Right? Ice is getting converted to liquid. Liquid is getting converted into gas. When I'm going to cool it down, once again, gas is getting into liquid droplets. Liquid droplets, if I'm going to further cool it down using a refrigerator, then we can convert it into ice. Right? So these are the main state changes that occur in this activity. Right. So let's head on with the next slide and let's see what are the other kinds of state transitions or state changes in matter. The third activity. Still we are going to find out or investigate or gain some idea about state changes, right? The third activity regarding this thing. So getting some understanding about the state changes. So third activity. In this activity, we'll be using iodine crystals. Okay, and we have to place it in a crucible like this, and we are going to heat that iodine crystals. Okay, we are going to heat that iodine crystal. So you know that usually when I'm going to heat a certain substance, right, from solid it is getting changed into a liquid. That's the usual way. That's the usual method, right? Any solid, when I'm going to heat it down, usually it's getting converted into liquid, my dear children. But in here, in this activity, I'm going to show you that there are some certain cases when I'm going to heat a solid substance, it's directly getting converted into a gas without going into a liquid, right? Without going into a liquid, it's getting directly converted into a gas. Then once again, when cooling down, that vapor, we can't observe the droplets or water droplets like in the earlier case. There is no droplet state. directly it is once again converted into a solid. Means that there are some certain situations when you heat up a solid, it's getting directly converted into a gas. There is no intermediate liquid state. And there are some gases, right? When you cool it down, it's getting directly converted into a solid, right? There are no any liquid intermediate state. So here we are going to investigate that kind of a example, right? So first of all, we'll name the materials, my dear children. What are the things you need? You will be needing a Bunsen burner. Bunsen burner. Then the tripod. Crucible. Iodine crystals. Iodine crystals. This instrument which is in here, this one, take the slide somewhat here so that you can see very clearly this thing. This instrument is called, my dear children, this one, this is called the clay triangle, right? It's made up with clay and it's a kind of a triangle. We can place it over the tripod to place this crucible, right? To place the crucible, we use this clay triangle, okay? Clay triangle. This is called as the clay triangle. So place this clay triangle over the tripod, right? So that we can place the crucible over it. It helps to place the crucible on the tripod, right? The clay triangle. The special instrument which used to hold this crucible. So when you are heating crucibles, we use these clay triangles, right? So these are the materials that we need then. So Bunsen burner, tripod, a crucible, some iodine crystals, and a clay triangle to place the crucible. So let's see how to conduct this activity then. Okay. So the method, what you have to do? We'll explain the method once again by drawing out a figure. Right. So let's draw out the figure then. The triangle. And the crucible like this. Then we have to place that iodine crystals. Within the crucible. Right. Then the Bunsen burner. Right, and you know that you have to place that clay triangle over here like this. Then to get a more quite good observations, you can use a piece of glass or else a glass sheet like in the earlier activity, and you can place it like this. When this iodine is going to evaporate, right, you can place a glass sheet over like this, right? Or else, my dear children, you can use, instead of a glass sheet, you can use a funnel, right? Or else if you want, you can use a funnel also, right? You can place a funnel like this. You can place a funnel like this. Like this, you can place a funnel, right? So when this one is going to evaporate, this vapor is going to hit on the surface of the funnel, and you can get a quite good or sound observation by that way also. You can place a funnel like this, or else you can place a sheet of glass so that you can get a good observation, right? Either way around, you have to keep it like this, right? And we have to heat up the system so that the iodine crystals will evaporate to create vapor, right? So we'll mark out the things given in here. So I'll remove that funnel thing. I'll just mention that glass sheet like this. So I'll take the slide somewhat up and we'll name it tripod, Bunsen burner, crucible with iodine, glass sheet. Bunsen burner, tripod, glass sheet. Instead of the glass sheet, I told you that you can use the funnel. Huh? Then next one, crucible with iodine. Right, then we'll write down the method. Method is really simple, my dear children. What you have to do, place the we'll write it in very simple like this. Arrange the system, arrange the system according to the figure. According to the figure. Heat it and evaporate iodine. Heat it and evaporate iodine. Place a glass sheet or funnel above the setup. Then observe. So this is the way of doing the experiment, right? So arrange the system according to the figure. So this is the figure. According to this figure, you have to arrange the system. Then heat it and evaporate iodine. We have to heat it and evaporate iodine, right? Place a glass sheet or else a funnel above the setup and observe. Right? So this is the way of conducting the experiment. Now let's head on to the lab and we'll conduct our experiment and let's see what are what is going to happen or what are our observations from this experiment and how to arrive into conclusion by using those observations. So let's head on to the lab, my dear children, and we'll conduct the activity. Right, my dear children, now we are about to discuss another state change, right? So in this activity, I have small bit of, so my dear children, these are iodine. These small balls are iodine crystals, right? So now I'm about to heat these iodine crystals and to observe whether these crystals are getting turned into a liquid or not. Now in the earlier cases, in earlier activities, when I was heating solid wax and when I was heating ice, first of all, ice turned into liquid water and then into a vapor. When I'm heating wax, solid wax turned into a liquid wax, right? So let's see what will happen when I'm going to heat these iodine crystals. So I'm using a crucible, and by using the crucible I'm going to add few iodine into the crucible like this. Then I'm going to heat it down, right? So I have added some iodine into the crucible. So I have added few pieces of iodine crystals here, right? So I'm going to keep it and heat the system to see what will happen in the instance change or the state change. So we'll heat up and see this iodine will turn into a liquid or not. So let's heat it. And while it is heating, I'm going to place this funnel on it. Right? You can see that the iodine is going to heat up gradually. So my dear children, you can see that here it's clear. Now iodine has not been turned into a liquid. You can see that a purple color gas is going to emit. See, a purple color gas is going to emit from the system. So I'll use this tissue paper. You can see a light purple color gas which is getting emitted from the system. A light purple color gas, see? Right. So my dear children, in here, in this instance change or in this state change, we can see that the iodine is directly getting converted into a gas like this, a small bit of a purple gas. It's getting directly converted into a gas. We can't observe the liquid nature of iodine. There is no liquid nature in iodine. Means that when I'm going to heat these iodine crystals, it's directly getting converted from solid to a gas. The intermediate liquid state cannot be observed, right? And on the walls, you can observe the solid nature of the iodine as well. If I'm going to cool it down somewhat further, we can observe the solid nature of the iodine as well, right? So here, the iodine has been converted into a gas straight from solid. We can't observe an intermediate state which is a liquid, right? So now I'm going to remove this funnel and I'm going to show you, right, that there is no There is no iodine left in the crucible. See? There is no iodine in the crucible. All the things has been converted into a gas. So this form of converting, this state of converting directly a solid into a gas is referred as sublimation. So this state change is referred as sublimation. When a solid is getting converted directly into a gas without the intermediate liquid state, this state change is referred as the sublimation. Right, my dear children? So all of these experiments which we conducted are related with the state changes, right? So we'll move on to the classroom to study further things related with the lesson. Right, my dear children, so we conducted the activity and you could see that, like I was explaining the experiment, you could observe that when iodine is going to heat up, there is no intermediate liquid state in it. It's getting directly converted into a gas. And when that gas is going to cool down, while it's going to hit that funnel or the glass sheet, right? So in that case, you could observe that once again, iodine crystals are getting created. Once again, iodine crystals are getting created. So in this case, you could see, or you can clearly observe, there is no intermediate liquid state during the state transition from solid to a gas. It's getting directly converted into a gas. There is no liquid state, right? So we'll write down our observation. When heating, iodine directly converts to gas. When heating, iodine directly converts to gas. It's getting directly converted into a gas. Then, upon cooling, vapor, iodine crystals are recreated. Right? So this is our observation. When heating, iodine directly converts to gas. It's getting directly converted into a gas. Upon cooling the vapor, right? Upon cooling the vapor by placing that sheet or the funnel, iodine crystals are recreated. So once again, we can utilize this gas to recreate iodine crystals. When I'm going to cool it down, once again, crystals are getting created, right? So this is our observation. So what is our final conclusion then? Iodine directly converts to gas from solid upon heating, right? So iodine directly converts to gas from solid upon heating. Then iodine vapor iodine vapor directly converts to iodine vapor directly converts to solid upon cooling. Right? Directly a solid getting converted into a gas. There is no intermediate liquid state. Right? And a gas is getting directly once again converted into a solid. There is no intermediate liquid state when you are heating iodine. This is the final conclusion that we can take from the experiment. Right? So there are two observations. When heating, iodine directly convert into a gas, and upon cooling, the vapor iodine crystals are again recreated. Right? Then conclusion is iodine directly converts to gas from solid upon heating, and iodine vapor directly converts to a solid upon cooling. This is our conclusion from the above observations. Right? So here we have discussed about several state changes, my dear children. Right? Several state changes. Solid is getting converted to a liquid upon heating. There are some solids which are getting directly converted into a gas once again upon heating. If you can cool down a vapor, we can recreate liquids. And if you again cool down liquids, we can recreate solids. There are some certain situations when you cool down a certain type of a gas, it's getting directly converted into a solid. There is no intermediate liquid state. So like that way, within these three experiments, we have changed the state of several materials. So let's identify what are these special state changes and what are they referred as. So here, you are given with a point. You would have observed that the wax melted when it was heated in a boiling tube. We observed that thing. Right? We observed that thing. You would have also observed that liquid wax turns into solid when it is allowed to cool. Right? We also observed that thing. When a solid substance is heated, it turns into the liquid state at a certain temperature. At a certain temperature, if you are going to heat, right? If you are going to heat a solid substance at a certain temperature, it's going to convert into a liquid, my dear children. That is what has happened to that solid ice upon heating. Right? In that activity over there, where we used to melt up ice by providing heat. When you are providing heat at a certain temperature, a solid is getting converted into a liquid. See, this is really important. The transition means conversion. During the conversion, after the conversion, or the converting process, right? So the transition of a substance from solid state to the liquid state is called melting or fusion. Now a special term which is given for the change of state from a solid to a liquid. The special term is melting or fusion. Converting or transition of a solid substance, right? Transition of a solid substance to the liquid state, or liquid to a liquid substance is called melting or fusion. It's referred as melting. So ice is going to melt or ice is going to fuse into a liquid water, right? Ice is going to fuse or ice is going to melt to turn into liquid water, right? So change in the state from a solid to a liquid is called fusion or melting, right? Then the next one, transition of a substance from the liquid state to solid state. Now the opposite term, transition of a substance from liquid to solid. Earlier it was solid to liquid, now liquid to solid. So transition of a substance from liquid to solid state is referred as freezing. Freezing. Freeze. You know that ice, when you are creating ice, solid is getting created. How come? By freezing water. When you are going to freeze water, solid ice is getting created. So transition of a substance from liquid state to a solid state is called as freezing. Freezing. Right, my dear children? It's called as freezing. So I'll take this one somewhat up. See, solid, liquid, solid and liquid. Turn in a solid into liquid state. Turn in the solid into liquid state. Solid into liquid. Solid state to liquid is called melting or fusion. Melting. Or another name is fusion. Melting or fusion. Then the second one, the opposite one of this thing, it's converting a liquid to solid. Liquid to solid. So converting a liquid to a solid, this is called as transition of a substance from liquid state to solid state, solid, liquid to solid. Transition of liquid into a solid is called freezing, freezing. Freezing. Right? So these are the two main state transitions, right? And their special names. Converting a solid to a liquid is called fusion or else melting. Conversion of a liquid substance to a solid is called freezing. It's called freezing. Right. So solid getting converted to a liquid. Ice is getting converted to water. In that process, the fusion or the melting. Liquid is getting converted into a solid. Right? Liquid is getting converted into a solid. Liquid water is getting converted into ice. That process is referred as freezing. Freezing. Right. So the state changes, my dear children. Okay, the two main ones. So let's see what are the other things contained in the state changing process. you would have observed that ice turns into water, and ice is a substance that exists in the solid state. We know that, right? Water is a liquid. The conversion of a substance from solid state to liquid state is also a change of state, and it is known as fusion. We discussed that thing, right? When that water is heated further, water vaporizes. So we know that if I'm going to heat that water once again, it's going to vaporize, creating a steam or water vapor. So my dear children, the next state transition. See, the change of a liquid into a gas is known as vaporization. It's referred as vaporization. The change of a liquid into a gas is known as vaporization. This is known as vaporization, my dear children. Vaporization. Changing a liquid into a gas. Right? Now in the earlier part we discussed changing ice into liquid water, and we referred that thing as changing ice into liquid water. We referred that thing as melting or fusion. Now in the second case, this liquid water is getting converted into water vapor. That process in which a liquid is getting converted into a gaseous substance, transition of a liquid into a gas, is known as vaporization. This is called as the vaporization. Vaporization. When water boils, formation of droplets of water on the glass plate can be observed. We observed that incident when I was conducting that experiment, right? These droplets were formed by the cooling of steam. These droplets were created due to cooling of steam. We discussed that thing also in the earlier case. I think you could remember. So once again, my dear children, the next state transition. See, the conversion of a substance that exists in the gaseous state into liquid state, right? From gaseous state to liquid state is called, this is called as condensation. So the next two state transitions, vaporization, converting a liquid into a gas, condensation, the reverse of that thing, converting gaseous thing into a liquid thing or liquid state, right? Converting gaseous substance into liquid substance is called condensation, and converting a liquid substance into a gaseous substance is called vaporization. Vaporization, condensation, right? So I'll take the slide somewhat up to write down those two state changes as well. So liquid, then here gas. Converting this liquid to gas. This is called as converting a liquid into a gas. See, change of a liquid into a gas, vaporization. Vaporization. Vaporization, my dear children. So liquid, vaporization, gas. Then the next one. The opposite of this thing. Gas. Right? If you take a gas, you know that gas can be converted into a form of a liquid. Liquid. This process is named as, see, conversion of a substance from gaseous state into liquid. Gaseous state to liquid. Condensation. 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 Right? So vaporization, condensation. The two state changes. Right, my dear children. So state changes. Okay? The terms given for the state changes. Right? So we have discussed now 4 changes and they are special names also. So let's head on with the next slide. Let's observe what are the other things contained in this state transition process. Right. Then the next one, the third activity. When crystals of iodine were heated in a crucible, you would have seen that iodine turned directly into a gas. We observed that thing. We conducted the experiment also. Right? So when that iodine gas was brought into contact with the glass surface, crystals of iodine can be seen on the surface. On the surface, and from this, it is clear that when iodine vapor cools, it directly turns into solid. Directly turns into solid iodine without becoming a liquid. See? When iodine gas was brought into contact with a glass surface, crystals of iodine can be seen on the surface, and from this it is observed that, or it is clear to us that when iodine vapor cools, it directly turns into solid iodine without becoming a liquid. I also explained this thing when I was doing the experiment, my dear children. It's a special kind of a case where iodine is getting directly converted into a gas without going into intermediate liquid state, right? So my dear children, the last 2 state changes and their special names. The turning of a solid into vapor without passing through the liquid state is also a change of state. Change of state, right? Right? There's no problem in converting a solid substance into a gas. Right? Intermediate liquid state is not there, but it's not a problem. However, the state is going to change. So this is known as sublimation. It's known as sublimation, right? So turning of a solid vapor, turning a solid into a vapor without passing through the liquid state, converting a solid directly into a gas, converting a solid directly into a gas, right? Turning of a solid into vapor without going into liquid. This is called as sublimation. Turning a solid into directly gas without going into liquid is called sublimation. Sublimation, right? Sublimation. Then the next one. During a change of state, no new substances are formed by changing the composition. Therefore, the changes of state are physical changes. So the most important one in physical changes, my dear children, is that if you take a certain type of a physical change, no new substances are getting created in physical change. In all of these experiments, when I was heating solid wax, when I was heating ice, and when I was heating iodine crystals, solid wax turns to liquid and liquid once again to solid. However, that is wax. Ice turned to liquid and liquid turned to vapor. However, it's water. Iodine solid turned to iodine vapor. Iodine vapor turned to iodine crystals or iodine solid once again. However, it's iodine. There are no new substances. The initial substances were the same substance even after the state change. So therefore, specialty in physical changes is that no new substances are getting created, right? So all of these state changes are good examples for physical changes. All of these things are physical changes. All of state transitions are physical changes, right? So my dear children, this is the specialty in physical changes. So state change, when you take any kind of a state change, liquid to solid, solid to liquid, gas to a liquid, gas to a solid, any state change, all of these things are considered as physical changes because during a state change, no new substances are getting created. Initial substances remains the same and their composition also remains the same. Right. So this is about the state transition then. Right, my dear children. So we have studied several special terms regarding our state transition process. Right. So we'll summarize these things then. We'll summarize. What are the special names given for these things? So I'll take the slide somewhat up so that you can see it very clearly. I'll start with solid first. Solid. Okay, solid. Then here, liquid. Gas. Solid, I'll use the same color, this pink color one, right, to indicate the transition under the pink color one. To indicate the opposite one, I'll use the blue color one so that you can get a good sound idea. Okay, right. So here, solid is getting converted to liquid. Solid is getting converted to liquid. Conversion of a solid to a liquid is called fusion or else melting. Fusion or melting. Once again, the opposite one. Opposite one. Liquid getting converted to solid. Liquid is getting converted to solid. Freezing. Freezing. It's called freezing. Liquid getting converted to solid. Check blue color with the blue color one and the pink color one with the pink color one, my dear children. Okay, right. So here, solid is getting converted to liquid under the fusion or the process of melting. Then liquid is getting converted into a solid under the freezing process, right? When a liquid is getting converted into a solid under the freezing process. So fusion or melting and freezing. Let's move on with the next one then. Right? Next one. Gas and liquid. Gas and liquid. So use the pink color one. First of all, gas is getting converted into a liquid. Gas is getting converted into a liquid. Condensation. Converting gas into a liquid is called condensation. Converting gas into a liquid is called condensation. Then the opposite one. Converting liquid into a gas. Converting liquid into a gas. Converting liquid into a gas. Converting liquid into a gas is called vaporization. Vaporization. Right? Vaporization. Converting liquid to a gas is called vaporization. Vaporization. Right? Vaporization. Then the next one. Gas and the solid. Gas and the solid. Converting solid substance directly into a gas. Converting a solid substance directly into a gas is called sublimation. Sublimation. Right? So this thing, what thing? Conversion of a gas into a solid. Like when we are cooling down that iodine vapor to create solid crystals of iodine. That name is not given. We never took an idea about that thing. We never took an idea about we never took a special term for that thing. So now I am about to give you that term. Especially here, conversion of a gas into a solid substance. Conversion of a gas into a solid substance. Gas into a solid. This is called deposition. 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 Converting gas directly into solid without going into liquid state is called deposition. Right? Deposition. So my dear children, these are the all state changes that we can observe during physical changes. Right? So what are these changes? Conversion of a gas into liquid. Conversion of a gas into liquid is called condensation. Conversion of a liquid to a gas is called vaporization. Conversion of a solid into a gas is called sublimation. Conversion of a gas into a solid is called deposition. Converting solid into a liquid is called fusion or melting. Finally, conversion of a liquid into a solid is called freezing. So these are the special names given for each of state transition that we can observe during the physical changes of matter. Right? Condensation, vaporization, fusion, melting, freezing, deposition and sublimation. Right, my dear children. So I hope that you took a sound knowledge about the physical changes and how to categorize physical changes under the state changes thing, and what are the special names which are given for the state transitions, right? And we discussed most importantly that all the physical changes are considered as, right? All the state changes are considered as physical changes because there are no any new substances which are getting created. Original substance remains the same. So my dear children, remember always, if you take a state transition, if you take a state change, all the state changes are physical changes as there are no new substances which are getting created. So I hope that you took a sound knowledge about the state changes regarding the physical change, right? So my dear children, that's the end of our next chapter, right? That's the end of our this chapter. So we'll discuss further things related with the lesson in our next chapter.